It's been 4 years since Cassini ended its mission by diving into the atmosphere of Saturn. Its mission was tremendously successful and it was one of the greatest missions of all time. The data it collected over the 13 years in the orbit around Saturn is still being pored over today, as there are still a lot of unsolved mysteries about Saturn and its moons. One of the most impressive discoveries of Cassini was confirming the existence of liquid methane lakes on the solar system's most unusual moon, Titan. But knowing they are there didn't help answer how they came into being. But now, scientists may have come up with the answer. Hello friends, I'm AK and today we will explore everything we know about Titan's lakes and what Cassini has seen and discovered. So let's start. There are only two places in the solar system that have stable bodies of liquid on their surface, the Earth and the Titan. That doesn't mean that they are very similar places though. Earth is a rocky planet with an iron core and silicate mantle. Titan is an icy world. Its crust and mantle are made up of mainly water ice, with a subsurface ocean of water surrounding a rocky core. This means Earth is a much denser and bigger in size, which means the gravity on Earth is a lot stronger than on Titan. Both the worlds have dense atmospheres, but due to their differences in gravity, Earth's atmosphere hugs the planet tightly, while Titan's, although a little more massive in total than the Earth, stretches hundreds of kilometers away from its surface. Their compositions are also different. Earth is much closer to the Sun, meaning it's much warmer than Titan, which allows there to be an active water cycle. Water is frozen solid on Titan. However, the temperature is just right for liquid methane to be present on its surface. That means Titan experiences a methane cycle in a similar fashion to Earth's water cycle. Methane clouds have been spotted in Titan's atmosphere, and these clouds rain liquid methane onto Titan's frigid surface. This process carves out rivers through the surface ice that flow into small seas or lakes. The data from Cassini visualized in these images clearly show various riverbeds and valleys cut away by the flowing methane. The most prominent of these flow channels are found around Titan's second largest lake, Ligeia Mare. These channels are special because they look to be much older than any other flow channel here. They have walls hundreds of meters tall with very steep slopes. Liquid methane is visible here, but right now it isn't flowing. Rather, it is likely to be a droned river valley due to the level of Ligeia Mare, although some higher altitude tributaries are likely to still be flowing down there. The lakes on Titan can be huge. The biggest one, the Kraken Mare, is even bigger than the Caspian Sea on Earth at roughly 400,000 km². The radar data suggests that a lot of these lakes are very shallow, some of them only a few meters deep. Some of the larger ones, however, can have depths of over 200 meters. The lakes of Titan are surprisingly still. Some lakes do not have ripples larger than about 1 millimeter, meaning it would appear like glass or a mirror. This came as a surprise to scientists who expected waves of up to a meter in height due to the low gravity and dense atmosphere blowing over the surface. This could mean that the lakes are a lot thicker than expected or that they occasionally freeze over. The detection of lakes on Titan wouldn't be possible without the aid of Cassini's radar instrument and infrared camera to see through Titan's thick haze. These instruments used a process called specular reflection to make observations. The radar instrument detected large dark patches across the surface, which were later confirmed to be lakes by the infrared camera. Specular reflection with the infrared camera and the sun ended up being used a lot to confirm what the radar secular reflection was seeing. Interestingly, clouds and the subsequent effects of the rain were also detected. In the left image, you see a light patch indicating dry ground, but a year later, the area was imaged again and this time darker patches can be seen, indicating a very flat surface, likely to be shallow and small lakes. The lakes aren't distributed evenly across the moon, rather most of them are found near the poles. However, the Huygens probe, which was part of the Cassini mission and landed on Titan's surface near the equator, did see flow channels around the equator too. At certain points in Titan's year, rain would fall in these parts and pool on the surface. However, these probably evaporate during the rest of the years and the rain migrates to the north and south, which is what Cassini and Huygens have observed. Even though Cassini was in orbit around Saturn for 13 years, that's not even half of the Saturnian year. Saturn takes a full 30 Earth years to orbit the Sun once. So Cassini didn't capture a complete picture of all the seasonal variations. The lakes likely vary in the depth throughout the year, with some potentially drying up completely. There is one other mystery that was thrown up by Cassini data to do with Titan's lakes that may have recently been solved. Some of Titan's smaller lakes have very steep rims that tower above the lake level. This is unusual as lakes on Earth typically form from erosion and dissolving limestone, meaning the rims are shallow and smooth. These are called karstic lakes. But this process doesn't add up for a number of Titan's lakes. Scientists now believe that these could be explosion craters that have since filled up with liquid methane. There is still a lot to be learned from the Cassini data. The lakes of Titan were just a small aspect of the mission, and scientists are going to be piecing these puzzles together for years to come, better understanding the Saturn system as a whole. Is life really possible on Titan? NASA has announced a new mission named Dragonfly to be landed on Titan. It will be launched in 2026 and reach its destination on the year 2034. Have you ever wondered what will happen if you fell into Neptune? I know that you are curious to know that. And yes, the next video is about that. So see you in the next video. See you there and goodbye till then.